Hi guys, my name is Pankaj Tandon. I've been working in the app dev space for close to 2 decades now, but I've been playing around with LLMs for the past 5 years, and it's certainly ramped up when uh, ChatGPT came out in November of 2022. So since then, I've been kind of tinkering around with LLMs, and as you know, it's a very fast-moving landscape. Things are changing really fast. On the LLM side, what we are here today to talk about is the app dev side. How do we use the LLMs? Not so much how do we train or fine-tune the LLMs. So I'd like to draw the distinction and just want to get a sense of the level of experience in the room. So how many of you have used an application? How many of you have used ChatGPT? I guess all of you, right? Yeah. And how many of you have used an application to interact with an LLM? So you guys, some of you have, okay. So we are going to be doing something in that space, and I just wanted to kind of talk about 3 areas which I thought are relevant. Now these are basics for some people, but I still want to go through that real quick. On the left you see training, then you can see fine-tuning, and finally you see the inference section. So inference is where you actually use the LLM to figure out, get answers. That first area, training and fine-tuning, is a pretty expensive field. You've got probably a dozen countries in the world, or companies in the world that are, or maybe more now, but of the order of hundreds of companies in the world who are training LLMs, because it's an expensive operation to do that. But the disadvantage in doing that is that you train with data which has a certain timestamp. So you train it up until a certain point in time, so that as of a certain, this little thing here, certain timestamp, and certainly it's not your data, right? So the data you train it on is public data most likely, and that's how the ChatGPT series of models have emerged, and of course the open source ones also. They are all on public data, and it takes a long time, costs a lot of money. So what happened is that if you want to ask it a question like, what's the capital of Colombia? You get the answer, because that's not a fast changing answer. But if you ask a question like, what's the drag count for a Boeing 747, which is a industry specific question, that data may not have been public when the LLM was trained. So you need to resort to something called fine tuning. And fine tuning is where you take the weights and biases in the LLM and you massage them through, I guess, similar algorithms, not the same, but similar transformers that are used in the training phase to tell it to give it biases and weights based on the airline data, which is specific to a certain industry. So it could be airline, could be banking, could be finance, or could be insurance, medical, whatever, right? So that's where fine-tuning comes in. That too costs money, and it takes a lot of time. So what do? If you have a question, so obviously you can answer a question like this. This kind of a question can be answered from a fine-tuned model, because it knows industry-specific information. So you can answer a question like that. But when you have a question like, I don't know if you can read it back there, but how many grams of daily protein do I need to lose 10 pounds? That's a question which is pertinent to me. And these LLMs have got no clue as to how to do that, right? Because it's my data, and it's current because my weight is current. So it's a question which I ask, which has to be answered as of today for me, and the LLMs kind of draw blank there. They can give you generic answers, but if you want to know about yourself, you don't know what to do. These LLMs will not suffice. So we'll talk about this problem space today. How do we handle personal data in a manner where you don't spend too much money, and it doesn't take too much time, and the turnaround is quick. So it's not like you got to train it for a month and then come back and ask a question. You're asking the question in a tight loop of a process which is tight looped. So that's what we'll talk about. Okay. So there are 3 tricks to kind of deal with this situation. One of them is Retrieval Augmented Generation, which is also called RAG. I mean, for short it's quite a mouthful, so just say RAG for Retrieval Augmented Generation. We'll talk a little bit about that right now, but not too much because I want to focus on function calling. I'll talk about RAG just enough to talk about how we can combine function calling and RAG. That's a kind of a very powerful paradigm, which I think it is, so I'd like to get your feedback, but we'll mainly focus on number 2, and then we'll focus on number 3 to the extent time allows. Okay? So any questions so far, please speak up, okay, if you have any questions. So let's talk about RAG, and like I said, this is not a deep dive, but just very, very short, so just make sure everyone knows what's going on. So obviously, in our previous slide, if I have to ask a question like, how much protein should I eat to lose 10 pounds of weight? If I had my medical records, let's say, my medical records, which are to do with my weight, my metabolism, or whatever, how I metabolize my food, let's assume I have that document. That's it, number 1. Find a corpus of text that is relevant to the query. So the query is, how can I lose 10 pounds? How much protein should I have to lose 10 pounds? So let's assume I've got my medical records. The next step in RAG is to break up that medical record into chunks of, let's say, 50 words each. And there are overlaps allowed, so it doesn't mean it has to be exact, but just 50 chunks of 50 words, let's say. We vectorize the chunks. There's a algorithm called word2vec. It's a very popular algorithm, very old algorithm actually, which converts, which basically identifies a semantic meaning of a chunk of text. It vectorizes it, and by giving it numbers, it puts it in vector space, which means that if there are 2 similar words like a apple and an orange, they'll probably be close, but an apple and a desk will be in different vector space. So vectorizing basically means just trying to give it a semantic direction and a semantic location in n-dimensional space. So you vectorize the chunks, then you vectorize the query. So the query was, how many pounds how much protein do I require to consume? So you vectorize the query, you vectorize the chunks. Then there is a mathematical process called cosine similarity, which basically tells you how close 2 vectors are in vector space, how similar they are. So let's assume we broke up a document and it came out to 10,000 chunks. We obviously do not want to, I guess I forgot to mention one thing. When you ask the LLM, you can essentially pass all the chunks to the LLM to ask the query. So basically that's called the context window. So you're basically stuffing the prompt with information saying that here's the my entire corpus of text, analyze that and tell me how many pounds of protein do I need. But if you did that, that'll cost a lot of money because the context window is going to be large, the number of tokens you consume is going to be large, so the LLM is going to hit your credit card, and you will be not too happy. So the idea is that we need to pass it out of the entire document, we need to pass it only those chunks that are relevant to the query. That is why when we vectorize it, we go to number 5, which is look for the chunks which are closest to the query. Unless the top 5 chunks, you get those top 5 chunks, stuff those in the query. And now you've got a much smaller context window, but hopefully more relevant to the query. And then the LLM has the relevant context, it will likely return favorable results because now it knows the top 5 chunks. It knows the ones that deal with protein, my metabolism, my weight, etc. Not the stuff that deals with my blood pressure, for example, I think. So the stuff which is not relevant to my medical records will be pushed down. The stuff which is relevant to my protein intake will be pushed up, and that's how I'll get the answer. And just real quick to make this complete, you can vectorize the chunks, and you can also hit something called a vector database. There are many databases. I think Elasticsearch also is vectorizing data now. It's supporting vector data. So there's a movement that lots of information is stored as vectors in vector databases with metadata about it. So it will tell you things like, here's your protein, here's a vector about protein, here's your blood pressure metadata, and here's the blood pressure information. So that's a vector database. So that's one. You can replace 1, 2, and 3 with hitting a vector database also, but that's how RAG works. Just let's keep this in the back of our mind because that's not really relevant to what we're going to talk next, which is function calling. But we'll come back to this, okay? So any questions on RAG? Yeah, please.
You mentioned the cost factor, but if, say, money was not an object, is there a difference in the quality? Like you have a large document, you just toss that document to the LLM, as opposed to vectorizing and selecting those chunks. Is there a difference in the quality of the response?
I don't know the answer to that. The reason is that internally, maybe the LLM does that, because the LLM, when we hit ChatGPT, for example, any of these LLMs now, they are not going to the engine directly. There's a whole layer of processing that happens before the query is sent to the LLM. So it's quite likely that the LLM layers outside are doing the same thing that we're doing. Maybe they're vectorizing it. So I don't know exactly. The answer, I guess, depends on different models. But I know for sure that there's this whole guardrails that are being built around these LLMs, and a part of the guardrails are to ensure that you process the query and you remove all the fluff, you remove the exactness. Sometimes you ask a question like, what do I do if my blood pressure is 150? The 150 part of the query is removed from the query because it is not adding semantics to it. It's giving exactness, and it's made into a variable. So all those kind of techniques are used before the query is given to the LLM. So for that reason, I cannot give a definitive answer. Okay, anything else on this? So now we'll talk about function calling, which is the subject of today's talk. So colorful picture, but I'll break it down. So let's see, we have this mouse here. Yeah, you can see the mouse. Okay, so this is our LLM that, let's say, is trained by, let's say it's the GPT series. Let's say it's or it's a LLM that knows nothing about you. It's set in time. It's as of 2023. So if you ask it the capital of Colombia, it will give you Bogota because the capital hasn't changed since then. But if you ask it things like, tell me about my health, no clue. So how do we handle it? So now we write an app. This red area here, let's say this is your company firewall. This is a protected area where whatever you write is not leaking out to the public. It's within your company firewall. You write an app. And let's say that the app, I've got a fictitious query which I'm going to be using, and let me go back to that query. Let's just look at this query. Suppose there's a query I have to ask. So I live in Pittsburgh. I love golf. In the fall of 2024, where should I fly to in Europe or United States to play where the weather is pleasant and it's economical too? Now this is a query I want to ask the LLM. If I want to ask this query, how do I use function calling to help me with this query? Let's talk about that. So here, since we asked about, we have a sense that, okay, the query I'm asking is the following. In the beginning, we need to start building a library of functions. A library. So it's not, so in this example, I've talked about weather API, weather service, and down here. A weather service, an airfare service, a currency exchange service, a financial service, and a recipe service. Now I've written this library of functions knowing that over time my questions can change. Today I want to ask about where do I go for golf in Europe or US, and for that I know I require the first four. I will require to answer information about weather, which is topical, it's current, and I want to know weather in the fall of 2024 when I want to go play golf. So I need the weather service. I need an airfare service because airfares keep changing, so I need to know what the current airfare is. I need this should be called currency exchange, actually. I wrote currency, but it's a currency exchange service. I need a currency exchange service because the airfare service may return fares in other currencies, in yuan or euros, etc. So I need a currency exchange service. I need a financial service because who knows how much money I have? The LLM doesn't know that. So if it's going to give me a vacation for $1 million, that probably won't work for me. So I need a financial service. And then, in anticipation of a future question, which I have purposely kind of written a recipe service, which has got nothing to do with playing golf, but I do write a recipe service, and I'll tell you why in a minute. But let's assume that I've got a library of five functions. which I have implemented myself, and they are all implemented within my company's firewall. So they're all inside this pink area here. And the data that is required by the service is also in the pink area. This database here is inside my company firewall. So it could be my, if it's a bank, obviously, then the credentials for accessing this data are also inside my firewall. That's important. The passwords, the usernames, which I'm using to access this secure data is not leaving my company firewall. So that's something I want to kind of draw out here. And then we've got external APIs. Now, in today's day and age, you almost never write an application that is self-contained. You're always going somewhere else to get answers. So we have a weather API, which I'll show you in the code when we go into the demo stage. I'll show you these APIs. So there's a weather API, there's an airfare API, a currency exchange API that these services are accessing. And these are public APIs. However, the keys to access these public APIs are again inside my application. They're not leaving my firewall. That's important. So how does function calling work? So we asked that question, where do I go to play golf in Europe or America? In fall of 2024, where do I go? That's a question that I've asked. What's going to happen is that we need to provide some information to the LLM saying that here is some information that the LLM may find useful to answer the question. That information is the metadata, not the implementation of these functions, but the description of what the functions do. Just a paragraph that describes the function, or maybe a line that describes, or a few words that describe the function. So basically we are sending the user query and the metadata that comprises these functions to the LLM, and based on that, the LLM, and we'll see more about this in a second here. Based on the metadata, the LLM is going to decide to invoke the appropriate function to answer the query. So it will decide. For example, if I ask the question that where do I, I want to play golf in a place which is economical and it's got good weather, the first thing a human being would do is, how much money this guy got? Is he broke, or is he a millionaire, or what, right? So the first thing he'll want to do is hit my financial service. So it'll get my bank balance from a financial service. Then it'll say, oh, let's think of the popular golf destinations. Now the popular golf destinations are some things that don't change over time. So that's most likely coming from the LLMs, from the pre-trained data. It's nothing to do with me. So the golf destinations, Myrtle Beach, Florida, Scotland, wherever else, Dubai, I guess, all those are already in the model. But now it requires to find out the weather in those places in the fall of 2024. So it'll invoke the weather service and so on. So now we'll see in the demo how this works. It's going to call these functions, and it may decide not to call them. That's the tricky part, where things are not deterministic, because these LLMs behave differently in different invocations, and we'll see that here. But the idea is that we only send the metadata to the LLM, not the implementations. That's a very key distinction. And the LLM, based on the metadata, will recommend, or will actually ask us which function to call, with what parameters, and then we will call the functions. We, as in this application, was going to call that function with the parameters that have been supplied to by the LLM. Like for example, here the LLM says, weather service, give me the average temperature in Scottsdale, Arizona in the fall of any year. So that's what this call is supposed to do. And then when this call comes in, we will call the weather API through the weather service, get an answer that, okay, the average temperature in Scottsdale is 80 degrees or 95 degrees, and send that data back to the LLM through number 5 here. And then the LLM may say, okay, I need to call the airfare service to see how much it costs to fly to where was this? Scottsdale from Pittsburgh, because he knows I live in Pittsburgh, because I mentioned that in the query, I live in Pittsburgh. So it'll say, okay, it'll call the FS service with the appropriate arguments, etc. And then, so this will continue on. This cycle of calling these functions will continue on till the LLM decides it no longer needs to call functions, and all it requires to do is call. Basically analyze all the results that it got from all the functions, and come up with a suggestion, recommendation, and that's when it comes out. So it basically repeats that, and finally, the final recommendation comes out after several calls. So this next slide talks about what the LLM is seeing. Okay, so this is kind of important. Back here, we were implementing this function, and the implementation of the weather service, airfare service, currency exchange service, etc., will have security credentials in it. So we don't want to expose that to the LLM. They can also be huge. So if you give the implementation to the LLM, that's going to cost you tokens. So we don't want to do that, because that's more money. The more tokens you give to the LLM, the more expensive it is. So you don't want to give the implementation. So what you give to the LLM is just metadata. So this is an example of the metadata. So here's a question. I live in Pittsburgh, PA. I love golf. In the fall of 2024, where should I fly to in Europe or in States to play where the weather is pleasant and it's economical too? Now, all I'm telling the LLM is, here's my FS service. This verbiage here is important, and you'll see this in the code. It says service that computes airfare starting from the origin and to the given destination. So and then there's a line that describes each input into that function. So origin is the city and state example, Pittsburgh, Pennsylvania, where we are flying from. Destination is the city and state where we are flying to. Now, these two examples will change with every invocation. It could be Scottsdale, it could be Scotland, it could be Dubai, whatever, right? So this is going to change. This most likely will not, because he knows I live in Pittsburgh, Pennsylvania. So we'll see that. And then there's this latitude and longitude. Now, this again is going to be supplied by the LLM coming back, saying, because Scottsdale is a big place, or San Francisco is a big place. So how does it know what the weather is like? So we require lat, what the airfare is like, because it has to find the closest airport, etc. So lat long is important. And so in the function that I've defined, this functions I've defined, I've also defined the metadata that for each input element that's going in. So I'm saying the longitude of the origin, and this is the definition of it, but the actual latitude and longitude is supplied by the LLM, because the LLM knows the langs and lots, the long and lat of these locations, because that hasn't changed over the years. That's from the training of the model itself. So when the query comes in from the LLM to our application, it'll have all these values filled in, saying that give me the airfare from Pittsburgh to Scottsdale, Arizona, latitude so and so, longitude so and so, destination latitude so and so, destination longitude so and so, in say August, and it'll figure out August because I've asked for fall. It'll figure out August, and it'll say year because I've asked for 2024. So it'll fill in these values and give it to you. And then what we do is we take those values. In our application, we go call the airfare service, get those values, and return the fare and the currency. And now if we return the currency in euros, which the airfare service does return sometimes, it'll decide to call the currency exchange service. But if the airfare is returned in USD, and if we are in US, and if most fares come in US, I've seen that it doesn't call the currency exchange service, only for the ones where the currency comes back in a non-USD currency, and so on. So it is deciding it basically, what I'm showing on this page is what the LLM is seeing. It's not seeing the implementation, and it is not, for example, in this question, it's not going to invoke this guy at all. Please, I've not seen it invoke the recipe service. But if it's a different question, how do I make an omelette, it'll probably invoke this in a different question, and then it will not invoke these guys. So what is invoked is left to the LLM, and that's the power of it. But the actual details are provided by us. So yeah, so that's important thing is that security is not leaking out, and implementation is not leaking out, which means you're not worried about passwords going out in the public domain, and you're not worried about high costs. That's important to keep in mind. Okay, so I'm going to just, any questions on this before we go ahead? Okay.
And the LLM itself is not making any of these service calls. It's your application
Correct.
that is making it.
It just,
and your application can validate these values. And like, for example, if the LLM says something here, like it comes back with August, but you really want September, like you can obviously.
On the way in and on the way back also, you're right.
Right.
That's, I never thought of that. That's a good point. So when the LLM comes back and says location Scottsdale, Arizona, and you say, Scottsdale is not right, I need to look for a closer town or something.
Right.
You can change that on the way in, and when the weather comes back here, and because we are looking for averages for a certain month, you can tweak that too. You can say, I know this weather service is always predicting high or something. You can titrate that and make it lower. So yeah, you have the ability to tweak that on the way in and the way out.
And the metaphor that I'm getting from this is the common saying is that either we know something or we know where to find it. And that's essentially what's happening. Either the LLM knows it or we're now telling it where you can find it.
And we're telling it in a manner which is kind of not expensive. That's it. We are telling it very small, relevant chunks of data. Yeah. Okay. Cool. I'll move ahead then. So this is what the LLM is seeing, and now we'll go into the demo phase. Okay. So I've got two demos. One is a Python-based notebook, and one is a Spring AI-based application. The Python notebook is kind of dated, it's a little old, but the advantage of the Python notebook is that that it's more explicit. You can see everything in one page. The Spring app is a lot of magic is happening in Spring under the covers, and you may just not see the forest for the trees all the way around, whatever. You're not seeing the details. So I want us to see the details, so I'll go into the Python notebook first. How many of you are Python developers? Almost a lot of half of you. And how about Java? Okay. Anyone has exposure to Spring before this? Spring AI? Or Spring rather? Just one? Okay. So we'll talk about Spring in detail then. So let's start with Python. Okay. So where's my okay, let me reconnect. I should have done this earlier, but okay. Oh, heck, I'm running on Wi-Fi. How did? Oh, this is on my. Sorry, I didn't even get on Wi-Fi. How do I get on Wi-Fi? Yeah, this was in my browser, so it worked. I didn't think about it. Also, if you could increase the text size of your browser by okay. Good. Yeah. Okay. So let me first. So my keys are stored on Google Drive. So there's a good pattern I picked up, and that's I think it's a cool way to do it. And when I say keys, I mean the API keys for these LLMs. Oh, okay. While this is happening, let's quickly go down and see what's happening here. So I've got two examples here. The first one is, can I buy a car worth 300,000 Indian rupees in the USA based on how much money I have in the bank? Okay. This is similar to what we talked about the vacation one, but this is a little older than the Spring AI project. So I just asked this question. So can I buy a car worth $300,000 in USA? And this is in Indian rupees. So now what I did for this is I first wrote a bunch of methods that, or other definitions, like functions, I guess, in Python. I wrote a bunch of functions that I anticipate would be required by this LLM to answer that kind of question. So I wrote some more also just to show redundancy, but at least the ones I think are relevant are get my bank balance, and this returns the bank balance in USD. remember the car cost is in Indian rupees, so it's not in USD, but my bank balance is in USD. It tells you the currency also. Then the routing number for my bank. So given a bank name, I want the routing number for the bank. And then just a function which takes no argument returns my account number. Obviously, in real life, it will take some kind of an ID, maybe or SSN or something. But in this example, it's not taking it's just returning an account number for my bank. And then, there's one more function, get name of the bank. So this one takes no function, no arguments, returns the name of a bank. So it returns this name, and this is used here. So using that bank name, it gets the routing number. So first get my bank name, then get the routing number based on the bank name, then get the account number, and finally, where's my, here, current exchange rate. Wait, I missed something here, what? Oh yeah, and now given the account number and the routing number, get my balance. So since we've got the routing number here, we've got the account number here, given these two, get my bank balance. And then there's one more for converting INR to USD, which is a trivial calculation right now, but all these have to be fleshed out. I mean, this represents what you would really do. So this stuff here, these 3 lines can become hundreds of lines in a real world application. So, and they'll have credentials in it also. So we want to keep that in mind, that this is a full-fledged application that you can within your company firewall. So we've got these things. And now we also have airfare between 2 locations, which is not relevant to this query. And we've got weather at a location, which is not relevant to the query. So this is a library of functions I'm building up. And then the main thing is I supply the metadata. This is the function metadata that I'm supplying to the LLM, not the implementations, just the metadata. So I'm saying the name of the function is this. What does it do? It returns the money, the amount of money I have in my bank account. The LLM is going to process this only. It'll read this and say, oh, this is how I get the guy's money in the bank. What do I need to get it? I need the account ID, because this is going to read this, and I need the routing number. So how do I get that? So now it's going to read further. It'll say, oh, this says that gets the account routing number, but it takes no argument. It just it gets get the routing number for a bank. So it just returns. There's no input argument, but it returns the name of the bank. And this one returns the name of the bank, and this one returns the account number. So it's going to look at all this metadata and figure out which function to call first. And based on that, and then finally, when it gets the balance in the bank, it'll say, okay, the car costs 300,000 Indian rupees. How much is that in USD? So it'll say, okay, it's this much in USD. So it's going to use this function to figure out if I can afford the car or not, and so on. So this is the metadata that is going to pass. And then it'll come and read this and say, airfare starting from origin to destination. So I don't need this for this query. So it'll ignore this, and it'll ignore this also. And then finally, so let's run the demo here. So I've installed this. I'll make my keys available. Didn't like that. Oh. Oh. Okay. Now here's my library of functions. So I'm going to just define these functions as my namespace. I'm going to now supply this metadata to the LLM, all this metadata. And granted, it is big, but we'll come to that in a minute here. But it's not as big as the implementations. That's the main thing, is the implementations will be much bigger than the description or the metadata. And now here is a function that, okay, so here's the first thing. I initiate the chat. So to the chat, I'll pass this query. So here's how I pass it. So here, initiate chat. Can I buy a car worth so-and-so in the USA based on how much money I have in the bank? Is going to call this. So let's run it, and then we'll talk about it in a minute here. So let's run it. So it calls some functions more than one time, but I'm not sure why. and it's also not repeatable. It's not deterministic. So if I run this again, I'll get something else. And that's good and bad in a way, so we'll talk about that in a minute. So here's the thing. So in the end, he says, based on your bank balance, you have so much money in your bank. The car you're looking to buy in India is worth so much. With the current exchange rate of so much, it's equivalent to so many USD. Given this, you can buy the car worth. So basically, it recommended that. So now let's see what it did. It called this function, name of my bank, with no arguments, because that function took no arguments. The function returned. Oh, there's a bug here. I think it should have. Oh. What is this? Okay, I'm not sure what that is. But anyway, it returned, it called the function this. It returned Chase as my bank. Then get routing number for bank with argument. So now it's used this output in this, and it's returning the routing number. And then it did this a couple of times. I'm not sure why it did it. A couple of times, but it did it 3 times. And then once it gets the routing number, it gets the account number for my bank. Then it called this again, and then based on the account number and the routing number, it got the balance in my bank account, and then it called the currency exchange to convert $300,000 into USD, and then finally it gave the recommendation. So it did go through the flow, and if I run it again, it'll do it slightly differently, which is a kind of a human trait, but we'll talk about that in a minute. So this is how the Python, and now we can just look at it real quick here in the code, because this is easier to look at this than the Java code. So I initiate the query, the chat, and I'm basically opening this completions API. I'm passing it. I'm building a message. The query is of type user. There are 3 roles. There's a user role, system role, and a function call role, I believe. I think it's called function role. So in this, the first go around, I'm giving it a user query, saying, here's a query, can I buy the car? That's the query given here. And then I call that, I pass the metadata to it. So that entire metadata data is being passed in the first go around. And then I check to see that in the response that I get back, I check to see if the finished reason is a function call. Sometimes it may happen that the LLM may decide that I don't want to call a function at all. I have all the information I require, and it doesn't call the function. In which case, this loop check will be false, and it'll basically go down here and give you the final recommendation, which most likely won't happen, because you want to answer those questions. So this function call loop basically says if it's function call, you basically in the response which comes back from the LLM the first time, it'll tell you what function to call. So it'll give you the function name to call, and it'll give you the arguments to call it with. So these 2 are very important responses that the LLM will give you the first time, saying that call this function with these arguments. So I go ahead in my Python program within my company firewall, I call this function with this argument, call the implemented function with that function name and the argument, and then I stuff the response back, which I get back from here, this function response. I put it back in the content, and I basically say this is the function name that I use to get the response for, and I give it a role of function, and I call the loop again. So basically, it keeps iterating over this loop, and now it says the next time it'll say call the next function to get the bank balance or the routing number, and it'll keep going till it comes back in the end and says, here's what I recommend. You can buy the car, you cannot buy the car. So this is Python, and this is it's all in one program. You can, and obviously if you make it more robust, this part will have to be beefed up. This definitions of the function will have to be beefed up. They'll probably need to be more secure and all that. So that's the Python part. Now we'll go to Spring. Any questions on Python before we go there? Okay. So Spring, first I'll demo it, and then we'll talk about the code, okay? So I have a demo. I've already compiled the program. This is how you invoke a Spring Boot application. You give it a Java command, and then this is the name of my jar file that has all the code in it. here's a query I'm asking it, same query we've been talking about, right? So that's a query. And then I'm supplying it the keys that are required. One key for OpenAI, LLM model, one key for Mistral AI, because I'm also using Mistral in another example. One key for visual crossing, that is the API that I'm using for, where did it go, this API here, this weather API, I'm using visual crossing, so that's that API here. Oh, did it? Yeah, this one, this API, that's that. And then, so this is the key for that. This is the Amadeus client which I'm using for airfare. So there's a web service that given the lat long of origin, lat long of destination, it finds the closest airport and then tells you the airfare. If it's in Europe, it'll give you in euros. If it's in America, it'll give you USD, etc. So that's that. So I'm passing these secrets on the command line. And then since I'm using OpenAI in this invocation, I'm passing it a profile called OpenAI. I could use Mistral also because I've implemented this with two LLMs, Mistral and OpenAI. So in this invocation, we're going to be using OpenAI. So I'll run that and we'll talk about the results and we'll go into the code, okay? So at conf financial service here, and because it needs to know how much money I have in the bank to be able to afford a vacation, right? So all this is happening between the application and the LLM. The user is just supplied his user query and he's waiting for the response. Okay, so we've got something. So let's go back here. The first thing it did was call financial service with request. It made this account number up because I did not supply it one, but it made it up, okay? So this account number is made up. But the account balance is coming from my service. And we look at the code in a minute here. And then it calls the weather service. It says location, because it decided that I can go to Phoenix, so it's at Phoenix. This lat long came from the LLM. I didn't supply that. Same thing, lat long. And he said I want it in Fahrenheit because we are in US, so Fahrenheit. Then it called for Lisbon, Portugal. It said here's the lat long weather service. What's the temperature in Celsius, because it's in Europe. And October, it decided to go with October. I'm not sure why. Sometimes it goes with August, sometimes October, because that's at fall, right? So it's using that. Then again, it says, oh, there's a response from the weather service. Temperature so-and-so, min, max, and average. And then now it's saying airfare. So it's in alert. I guess we're safe. Okay. All right. So then it goes for the airfare service. It says flying, because I said I live in Pittsburgh. It's looking Pittsburgh to Phoenix, and it's giving the lat long of the destination and the origin. And the airfare service says it costs average airfare in October of 2024 is going to be so much. The currency, for some reason, it's saying euro. I don't know why. This airfare service, this is a real service it's hitting. So maybe they are returning it in euros, but that's fine. And then for Pittsburgh to Lisbon, same thing. It's $490, 490 euros. And then they use the currency exchange to figure out how much it's in USD. And then finally it says, given your bank balance of $1,500, both destinations are economically viable. However, Phoenix is significantly more affordable and also offers warmer temperatures, which might be preferable for golf. Thus, Phoenix, Arizona may be the place to go, right? So that's one invocation. I'll bet if I run it again, it'll come up with a different recommendation, but that's okay. The main thing I want to kind of point out is that it's calling the functions that I expected it to call. It did not call the functions I did not expect it to call, like the recipe one, but I just did supply everything to the LLM, and it called the rate function. Sometimes it doesn't. Sometimes if the airfare is returned in only USD, it doesn't even call the currency exchange service. So there's that. So now let's look at the code. So a Spring application, and since there are very few folks who have got exposure to Spring, I'll just say a few things about Spring. What it does is it allows you to starts up when you start a Spring application, a Spring container is started, and some of your code which is running services is instantiated in what is called a Java bean. It's called a bean. So basically, it only for example, the AFA service, you don't have to instantiate it. If you wanted a financial service or an AFA service, you don't have to write in Java. You'd say new AFA service. Spring will do that for you. So it basically instantiates the services you require in a Spring container and makes it available for anyone who wants to use them. So the life cycle management of the services is done by the Spring container, and that removes it kind of incorporates a lot of best practices in it, because if people were doing it themselves, they could do shoddy work like not close transactions and stuff like that. Spring takes care of all that for you, and you focus on the business logic to call the services or to implement the services. In the same spirit, what Spring is doing now is, in this directory you see here, I've got AFA service. IntelliJ is hanging over there. All right, something has to go wrong. Let me kill this and bring it again. Okay, so while this comes up, so the services that are being used are implemented like Spring Beans. That's the important thing. That we are, just like you have a financial service that may not use any Spring AI. Oh, I forgot to mention one thing. So Spring has got an umbrella of projects. It's got projects for manifesting something in the web. So you can also have an application that's got nothing to do with the web at all. But the view on the street is that most things are now exposed to the web. So Spring has got a very popular project called Spring MVC, which allows you to take any application and expose it to the web. But like I said, it's not necessary an application has a web component. But if it does, then Spring MVC is one very old and very solid project that's been there for many years. The Spring MVC, Spring security for OAuth 2 implementations. Then you've got Spring integration for talking to various external entities using channel adapters and so on. And then you've got probably, I would say, about 50 projects under the Spring umbrella. The newest one, or one of the newest ones, is Spring AI. So the good folks at Spring came up with this, you can say, middleware that incorporates the best practices and abstracts out all the idiosyncrasies of these LLMs in a common interface. So we don't have to deal with, like for example, if you use a chat client, you can use an OpenAI chat client, or you can use a Mistral chat client, or you can use an XYZ chat client. So the interface chat client is implemented by many of these APIs under the covers. So basically, Spring homogenizes the use of these disparate LLMs or APIs under one umbrella. That's one of the powers of Spring. So given that, what we have here is, this is so these services, the AFS service, the currency exchange service, financial service, weather service. These are 4 services I implemented just like I would any other service. So for example, at the same level as these services, you could have a tax service, or you could have a food service, anything else which does not have anything to do with the bank or with your Spring AI. So Spring AI services are just like any other service, and they can be injected into each other. That's a very key thing in Spring. You can take one service, and let's say my tax service uses my financial service. you can actually inject your financial service into your tax service and make it more powerful. So you can build your code modularly in different services, but Spring allows you to hydrate these services by injecting one into the other and making it more robust. So in that same spirit, these Spring AI services that we have here can be injected into each other, and some of them may be using Spring AI, some may not. In this example, we've got all these four services do use Spring AI, but what I wanted to say was the same pattern can be incorporated in an existing code base that you may have, and you may decide to write a Spring service that uses Spring AI, and it'll sit alongside your other insurance service or medical service, and here's a Spring AI service that does something. So that's the smooth way with which Spring brings this integration with LLMs is really neat to watch. So here's the AFA service. Let me just go through one of them. So the main thing, and this is all Java stuff, this has got nothing to do with Spring. We are implementing an interface called function, and the function takes in a request and a response. So this is plain Java stuff. It's not Spring specific. So we are writing an AFA service that implements this interface, which is a request and a response. And if you look at the request, here the request has got, this is the actual metadata I was talking about, which is actually specified as an annotation in the service. So this tells the LLM, and so basically all we do is write the service, and we specify the description of the top level service here, and the description of each, like this is the argument, or this is the argument to the method, this is the description to the argument of the argument, this is the next argument, description of the argument. So we are basically doing the same thing for all the arguments that go into the method called AFA service, which basically does this, right? So it does this, and the LLM knows this by reading this, and it'll read all this stuff to figure out what each argument does. And once we have the service, we implement it as a function, which is, where is it gone? Like here, the request and the response. The response is similarly, if you go here, the response returns the airfare and the currency in which it's returned. So this is something that we were seeing back here, right? So airfare, responses, airfare, and currency. This corresponds directly to this and this. The word airfare and the word currency are here and here. Similarly, if you look on the way in, this is a request, origin, destination, currency, origin, longitude, latitude are basically, where did it go? These. So you can build this method in this manner, and then all you've got to do is implement the apply method, which belongs to the function interface, and give the request. And there's nothing else to do. Spring takes care of everything else. Of course, you define this method like this. You define get the closest airport. So I'm calling the API to get the closest airport. This method here is implemented down here, where I'm making a REST call to that API here to get the closest airport. Then I get the closest airport from the destination, given a lat and long. So basically, given a lat and long, I'm calling the API to get the closest airport. Then I call, now that I've got the closest airport, original airport and closest destination airport to a certain lat and long, I call shop for flights for lowest airfare, given the closest airport, and so this function returns the IATA code, which is like a 3-letter mnemonic for every airport. So it returns that. So now to this shop flights for lowest fare, I basically go and hit this API, and I pass it the IATA code for the closest airport to origin and closest airport to destination, and this guy comes back with a flight offer. Oops. And the flight offer, then from the flight offer, I get the price from it, and I put it in this response. So there's the airfare, and there's the currency. So basically, we get the currency back in this manner. And then the key where the whole thing comes together is this vacation service. Well, I'm calling the chat model. No, sorry, not this. OpenAI config. This is where I'm basically calling the model with this function, this function, this function, these 4 functions, which pretty much map to sorry, where it go? These names. So these are how you configure Spring Bean. So you're mapping these function names and you're calling it in the configuration, in the application configuration context, like this. Yeah, like this, but you're calling it like this. So that's all you have to do. And Spring will extract those descriptions of the class name and each argument and give it to the LLM. The LLM will do its thing and it'll marshal it back and give it to you. So it's a very simple, the usage of Spring is very simple in Spring because you don't have to do all that fine tuning which we're doing in Python. So that's I'll stop here because if anyone is interested, this is all on GitHub, so you can look at the code whenever you feel like doing it, and reach out to me if you have any questions. Unless you have questions now, please speak up. Otherwise, I want to go to the next part. How are we doing time-wise? Are we good?
Yeah, you're doing all right.
Okay. I'll take about 10 minutes more. Okay. So, yeah. So that's, and like I said, the code is all there for you to see. And obviously, it's difficult to talk about this in detail for folks who have not worked with Spring. But if you do get to that point in your progression, and if you'd like to do it, please reach out to me. So that's how this works. So let's go back to the slideshow here. So we talked about these two. Okay, this is the question we talked about. Okay. So this is kind of a very philosophical question, okay? So what does the LLM in all this do anyway? So we are providing it all the data. What is the LLM doing for us? My interpretation is that the LLM is dealing with multiple dimensions. So what happens is, for example, if I want to say that I'm feeling hungry, I want to go for fancy dinner, sometimes my comfort wins out and sometimes my bank balance wins out. Sometimes I say I don't want to spend $100 to go in for a fancy dinner, but sometimes I say it's worth it. So there are 2 dimensions. One is finance, one is my comfort. But in a real life, in a situation like that question I asked about where can I go for golf, there's weather involved, there's finance involved, there's what else? Yeah, there could be things like, suppose I'm a heart patient. I want to go somewhere where I can be near a hospital. So I want to factor that in also, that when I'm going for golf, I want to go to Scotland, but if I'm in the boonies somewhere and there's no hospital, if I get a heart attack, I don't want to go there. So there's that to consider. Then there's things could be the golf course rating. Suppose the golf courses, I want to go to a fancy golf course, so the rating is also important. Or there could be celebrity sightings. So I see Tiger Woods has played there, it's a big deal, I go there, right? So when there's so many dimensions, our brain starts fusing out. We don't know what to say. I mean, if you ask me today, I'll say I'll go to Scotland, but if you ask me tomorrow, I'll say no, it's too expensive, I want to go to Phoenix. So just like that, when you've got one dimension is a simple answer that you know which the highest value you choose it. When you got 2 dimensions or you got 3 dimensions, you can kind of figure it out as a human. But when you've got multiple dimensions like we have here, and the answers to each dimension have been supplied through a function, tying it all together is where the LLM comes in. That's where the training of the LLM, which is maybe 2 years old, is still relevant to us because it's dealing with multiple dimensions and it's trying to come up with an answer that makes sense. That is why if you ask it the question the second time, it may come up with a different answer. And that's how humans do it too. If you ask me today, I'll say, oh, I want to go to a fancy restaurant. Tomorrow, if you ask me, maybe not. It's too expensive for me. So that temperature variable in the LLM is what controls this, which controls the deterministic behavior of these LLMs. And like I said, it's as capricious as we are. Sometimes you want to do something, sometimes you want to do something else. So the LLM is what ties these dimensions together. And the dimension values are supplied, can be supplied through these functions. So that's what we have to take away. So whenever you have to, the question to ask is, where's the LLM, what is the LLM doing and what am I doing? So I'm supplying the values to these dimensions, and the LLMs is quarterbacking the whole thing for us. It's saying, okay, you got this value, this value, this value, maybe you should do this. So that's what I got out of that. Okay, so this is an interesting thing, combining RAG and function calling. And that's the last topic. So if you're fusing out, just stay with me for some more time. When we talked about RAG, and I have the slide here, this information that is being sent to the LLM can get pretty verbose. Over time, if you start building out this library, today we've got what, 1, 2, 3, 4, 5 functions. Tomorrow we can have 100 functions, or I mean, next month we can have 100 functions, because as we keep building out our application, we keep adding more and more functions. So now we are sending out all this data with every prompt. We are sending 100 metadata values to the LLM so that it can decide which function to call, realizing that some of the functions, like this recipe function, may not even be relevant to the question. So here's where RAG comes in. What we can do is, and I'm working on that enhancement in Spring AI nowadays. What I'm working on is that when we supply these functions, we are going to take we're going to extract these values. Basically, the metadata of each function, we're going to extract that. We're going to vectorize them, just like we talked in RAG. And all these functions, all these metadata of the function is going to be vectorized, and we are then going to find, we are only going to send that metadata that is relevant to this query. So this recipe one won't make it for this query because it's in a completely different vector space. But this one will make it. So basically we are trying to cut down on the data, the metadata that's being sent to the LLM to decide what to call. So that's how we can combine RAG and function calling, because metadata itself becomes expensive to send to the LLM, right? So that's where we'll, and this was an interesting, interesting bit of information that came out just 5 days ago. Jan LeCun, who's the CEO of Meta, told the community at large to stop working on LLMs because he feels that the pace of LLM development is far outpacing the pace of application development for LLMs. So he said stop working on LLMs. He said many more things, but one of the things he said was do not work on LLMs, work on the app space to kind of balance it out, to make sure that we are using these LLMs also in a powerful way. So that was the thing I got from this talk. So I thought I'd share that with you.
Stop working on engines, build more cars.
There you go. That's a good analogy, yeah. Yeah, so that's...
And he loves to insult on LLMs and that it's reached the limits of its applicability.
Yeah, according to him, it's, yeah, he's saying that too, yes, that's right. He's a funny guy. And he's quite contrary to, his views are quite contrary to other people. Sorry, listen.
No, if I can understand the value of bringing the beans, would it be right to say that if you have like 3 banks,
okay,
like say PNC, Chase, and JP Morgan, each one has a proprietary API. What the Spring Bank service does is that you only write through the Spring Bank service, and it automatically translates it
Yeah.
to, that's essentially
Yes.
what it is giving you. So if we needed to switch banks, on the Python version, you would have had to rewrite
Right,
the
right,
thing,
right.
whereas here,
Yeah.
it just happens
You
automatically.
it kind of happens through a good coding practice that Spring is based on, which is coding to interfaces.
Right.
Spring is all coding to interface. If you
Right.
look at Spring code, you'll have a class with about a dozen interfaces.
Correct.
So coding to interfaces is so ingrained in Spring
Yes.
that when you write a Spring, a class that is managed by Spring, you'll tend to write as an interface, right?
Correct.
Then you can swap out the bank.
Yes.
Yes, so that's the advantage. So, okay, I guess I'm.
If you haven't already, you should consider writing this up as a Medium article or something like that.
I did write it actually.
You did?
Yeah, many years ago, many months ago.
Okay.
But I kind of forgot it. I forgot to
And
publish it. Yeah.
points to the code?
No, that was written before the code. I started contributing to Spring AI actually. So when I started contributing to Spring AI, that was later on. But the function calling article I wrote about 10 months ago. It's on the meetup invite. So you can get a link to it. So if any questions, this is the time, or let me see if I missed something here. LLM's doing, oh, that's it. Yeah.
Yeah, right now when it comes to function calling, the interface is purely string-based.
Everything is string based. Everything is string based. LLMs only talk strings.
And so at times you can get away with having a list of something, a list of strings as an input on occasion, but the output that's returned back from any tool call, that always has to be string, right? It can never be, an LLM is never going to make sense of, for the time being. It's not
So
going to make sense of an object.
not an object, but JSON as string. So it does that.
Okay.
So that's what we are seeing here. So if you look at this, it's returning. Okay, actually I haven't. Maybe I should show you in the code. So in the code, it returns this as a JSON object, and why it does that is, so I've specified the response as a airfare and currency. It returns it as a JSON string. So it does that because maybe it's figuring it out from the request that's being sent, that's JSON, so it returns the response in JSON, but as a string. So you have to marshal that into an object if you're writing it in Java or something, Python. So yeah.
Is this similar to what Apple's doing with like Apple Intelligence, where like they're having it integrated within the phone, and then like at some point they're sending it out to ChatGPT?
I don't know if it's doing this exactly, but all I know is that these LLM companies have now got a lot of energy in building the layers around it, especially for misuse and stuff like that, and even verifying that that the machine is not hallucinating. So that there's a lot of energy being put in the area outside it. Whether it's using function calling or not, I do not know. I do not know.
I think they have a local model that they do, but it's computationally complex.
Okay.
They send it out to OpenAI.
Oh, really?
Yeah.
Okay.
Yeah,
So I think it follows the same framework where, hey, this is a simple question that doesn't change very often versus something that's like dynamic that could change a lot.
Oh yeah, yeah. Like I was saying, one more thing I read was that when queries have got embedded data in it, like for example, show me all cities that have got a temperature of 72 degrees in December. Let's say that 72 degrees there is removed from the query. It's the rest of the query is vectorized, because if you vectorize the 72 degrees also, that will change the semantics of the whole query. So they remove that, make it a variable, and vectorize that, and then look for the semantics to see which queries are similar to that. So there's that whole query engineering piece. The query is totally broken up, and I don't know how they do it, but there's a lot of stuff going on in that area. Whether they could be using function calling in that area also, but I don't think they use it like we do it. You know, we are app developers, and for app developers, the tool chain is totally different, as against what would be used by people who are in the guts of the LLM itself, or even in those outer layers. They're not going to be using Python. They'll be using maybe Python, I guess, but mainly C functions, low-level functions. They won't be writing high-level code like this. But the concept is the same, I guess, function calling. Yeah.
It might be a generic LLM question, but can you ask the LLM to provide a reasoning?
Reasoning.
Yeah.
Yeah, I read about that, and it's a subject I have an opinion on, but I don't know if it's verified. So I mean, I'm only giving you my opinion. I don't think this is pure and simple pattern matching. There's no reasoning at all in LLM. That's my opinion. I'm not sure if other people agree with that or not, but that's a subject for debate, and a lot of people are talking about it. What do you call that? What do you mean by reasoning? In my opinion, this is hardcore word prediction, pattern prediction. That's what it is. There's no reasoning at all. Even though you can use language somehow provides a buffer between reasoning and reality. So what happens is you corral reasoning into language, and we are writing the language pattern match to make it sound like reasoning, because in the end you can only represent reasoning in language. So that's what happens, but it's not quintessential reason.
That's Jan LeCun's biggest.
Yeah, that's his main thing. Yeah, that's his main point, that it's not reasoning at all.
I was wondering, this is kind of a little bit Spring centric of a question, but I'm probably like most people. I'm familiar with OpenAI. I've used it, and so I was just curious because you know how like you can pull in dependencies for specifically the OpenAI version of Spring AI or the Mistral AI, like or something else. How different are they from each other? Are they once you load them in, like if if I'm working on Mistral or if I'm working on OpenAI, like once I load it in, you just kind of do you lose track of the dependency itself? Similarly, like if you're using Postgres or MySQL, you pull in the dependency for Postgres, and then after that you forget about it. And Spring just you don't even notice which one you brought in. Is it similar with Mist, where you just
Yeah, it is similar. It is similar. I think you are touching upon a question which predates Spring AI. The question which you're asking is applicable to any dependency. How do you ensure that you're just not getting a big fat jar with all dependencies in it? Is that what you're saying? How do you?
Yeah, kind of, right. Like exactly like
Yeah.
Right. How would I exactly? Like,
How do you make it slimmer and faster?
yeah, because I'm wondering what's underneath the covers. Is it like everything? How big is it?
So my answer to that is that the way to handle that is using starters. Spring Boot starters.
Oh, okay, yeah, right.
Spring Boot starters is what provides in the POM or in the Gradle file. There's something called optional dependencies. So optional dependencies are those that are pulled into the jar only if invoked, and it's called optional. And Spring Boot starters use optional. So basically, to do it correctly, you'll have to make a OpenAI starter for your company and a Mistral starter for your company, and then you mark those dependencies as optional. And by doing that, only those dependencies will be pulled in. And you can do that with Postgres and MySQL also. The same thing.
Okay.
If you look at the Postgres, there's a starter for Postgres, starter for MySQL. The same thing is happening. If you look at the source code of that, the same thing is happening. They have these dependencies marked as optional.
That makes perfect sense.
Yeah.
That's helpful.
Yeah. Any other questions? Yeah, please. Yeah, go ahead.
When you say optional, does it mean that you put it at runtime or?
Yes, runtime.
And also, in terms of developing frameworks around something like function calling, right now it's all string based, but maybe you can go one step further. Are there people who are looking into doing that, or are most people like maybe the next big company is going to come up with an improvement that's going to make that framework completely obsolete, for example? Where exactly do you think?
I was talking to one of the people from the Spring, one of the main committers, Dr. Polak. He's one of the main committers in the Spring AI framework. and I was trying to get a sense of the same question, that everything is string based in LLMs, right? So what is the next step? How are we going to, what's going to be coming down the pike? He didn't give me a clear answer, but based on the code I'm seeing, everyone's building a layer around the strings. So basically they're marshalling the strings into whatever object you want. And the next big thing, see, LLMs are intrinsically string based. That's the whole thing, that matching words and depicting the next word, it's a string, right? They're intrinsically string based, but what they output can be marshaled into a high level object, or something else, maybe some other object which has got distinct properties. So unless we move away from LLMs, I don't think we're going to move away from strings. Strings are they're the lingua franca of LLMs. That's what they talk on, right? The whole thing.
Language is strings.
Yeah, strings is the main thing in LLMs, because it's all about creating the next word, right? So I don't know if we can get away from that. At least I don't know how any other way. And like I said, if we move away from LLMs, then maybe. But I don't know. In LLMs, it's all been strings, I guess.
If I can circle back to what that gentleman raised about reasoning, I'm reminded of this quote of Dijkstra, where he said that asking whether a computer can reason is like asking whether a submarine can swim.
Oh.
And who cares? Like, what does it mean that I can, if you can go underneath water, that's what it means to swim. Okay, then a submarine swims, a fish also swims there. So in that way, as long as we treat it as a black box, okay, well, like what happens inside may be very different from what happens inside us. But again, who cares?
There's that famous Chinese problem where someone was slipping notes under a drawer, right?
Chinese room argument.
Yeah, argument. Yeah, the same thing. Yeah, that's a good question, but it's one of those things you can keep talking about, but it's semantics, right? In the end, I mean, in a very fundamental way, reasoning is.
I think reasoning is integral, and that I am of the LeCun. I'm a big fan of his because I studied at University of Montreal. It was like in sociology and stuff, so not specifically AI, but a lot of kind of in that vein of quantitative analysis and predictive analytics. And I it's hard to put into words, but I really feel that one time he described the LLM as like saran wrap that covers the reality of what it's describing, and it's literally just as thick as saran wrap, and like you can get it. Okay, cool, that's great. That's like I get the answer, and but it's wrapped in saran wrap, so you just like remove it, and there's nothing behind it. So, I don't know. It's head games kind of.
Yeah.
I see what you mean. It's like It's like the submarine is underwater. I'm getting my answer. I don't really need the reasoning, So, on the one hand, part of me is like, yeah, go LeCun, and then part of me is like, I don't know. If it's like a philosophical question,
and it's even difficult to answer. Sometimes this whole explainability issue is so complex. Even if you can look under the covers, if there are like 100 dimensions, how do you know what is happening? How do you know? How do you explain something like in the example I was saying that this is kind of a very important to me. It's important that when you look at this, here we've got 5 things to look at. So you can say, okay, if you look at these 5 dimensions, you can say, okay, I know why he's saying I should go to Scotland because of this. But now imagine these are 100 dimensions here, and the guy comes up with the recommendation, no, you should go to Myrtle Beach. Now the question is, how did he come up with that? Because you don't know how to process those so many dimensions, and humans don't do that. So the question of explainability is very difficult. It's a very difficult one. Even if you can look under the covers, you cannot explain how these dimensions are processed.
And even if we had like a 1700s Pascal with perfect reasoning logic from step to step to step, like that would satisfy us. But here, like, what's wrong with the computer going like the opposite way, like 1,000 miles step by step by step,
and coming back,
it's the same thing. It's so valid.
Yeah. Cool. And if you guys excited about this function calling, did you think you can build something with this?
This is awesome.
Yeah.
How to do it? I mean, because
It's so cool what it does. Really, very very. Especially it tells you the steps that it's calling these functions. Beautiful to see that.
is there? I'm sorry. Is there any like real world application that's built on this?
You know where it all falls apart is the predictability aspect, the non-deterministic aspect. We can do this, we can fine-tune this, but if you run it again, you get a different answer. If your end application can kind of have the appetite to deal with that uncertainty, then it's a real world application. But it's like a human, you know, if you go to because not like in these dimensions here, you can get the exact value of weather, exact value of airfare, exact bank balance, exact proximity to health facilities. But now the final recommendation, if you ask me today, I'll say something, tomorrow I'll say something else. So in that sense, it's mimicking a human being. You know, it's as capricious as a human being in that sense. But whether it's real world or not, the definition has to slightly change, you know, because it's non-deterministic. That's the only problem.
I mean, like, are there any like companies that are like doing this stuff in the back?
I think everyone is
Yeah, I know.
nibbling.
Like, EHS right now is deploying an LLM model, a chatbot essentially to answer some questions, but it's I forget how they like decided on which chatbot, but there's a ton of companies that are deploying things like this for a wide range from chatbots to self-documentation to who knows. I mean, even Sports Illustrated was using people to write that. But you know, I think we're a little low on time, and with the weather, we should probably like start wrapping things up. So, and there's also a bar downstairs that we could also continue the discussion at. I own the bar, so it helps me a lot if you drink it. I'm joking. I actually don't own the bar.
If you own the bar, it'd be pretty cool.
Very well presented.
Oh, thank you so much. Thank you.